So, dear students, let us start our class now. So, we will start with the topic called finding the maximum and minimum values of a quadratic rational function. And also we will see that how to solve, few problems based on the concept what we are going to be learned in the next few minutes.
I can't see a digital book.
Oh, okay. Okay. All right. Let me share with you. Thanks for the information. Could you please confirm that you are able to view it now?
Yes,
Yes, sir,
sir.
now we can see.
Okay, great. So here, what we're going to do, dear students, is that, suppose we have a quadratic, function, both numerator and denominator is a quadratic function. So what kind of function it should be? So we get a function something like this. That let me give you an example, so it will be more clear. Suppose we get you know, a question something, in an expression something like that: x square plus 3x plus 7 divided by 2x square plus 7x plus 8. Suppose we are going to find the maximum and minimum value of this expression. Now the moment we write it as y is equal to this, then it becomes a function. Correct? So what we are going to learn that how to find the maximum and minimum values of this kind of function. So what is the generic description of this function, if you see? So this I have given example. If you see a generic expression is something like this, that y is equal to, ax square plus bx plus c divided by denominator px square plus qx plus r. Suppose this is our generic, quadratic rational function. Now, what we are going to find, as you know, as I said in a few minutes back, we are going to find the maximum or minimum value of y. Now, the moment we get y equal to this, so what we can write? We can write that y into px square plus qx plus r is equal to ax square plus bx plus c. Now from here, what we are going to do, dear students? We are going to find it, we are going to form a quadratic equation in x. So to form a quadratic equation in x, so what we are going to do? A minus py into x square, a minus py into x square plus b minus qy into x, b minus qy into x plus c minus r into y. This is equal to 0. This is a quadratic equation in x. Correct, dear students? Now let's look into it. What we understood? We understood that x is real. Now as x is real, then the discriminant of this equation we just derived, suppose we give this equation as 1, the discriminant of this equation must be greater than equal to 0. Obvious. So if the discriminant of this equation is greater than equal to 0, what we are going to find then? We are going to find that b minus qy, so I can write it down as x is real, discriminant of the above equation is greater than equal to 0. So what is the discriminant, dear students? So b minus qy, b square minus 4 into a is a minus py into c, it is c minus ry is equal to 0. So b square minus 4ac equal to 0. Now from there, what we are going to find? If you look into this, quadratic, inequation, you are going to find the ranges of values of x and y. Okay, and those ranges of values of x and y is going to give you a proper, a decision that to make sure that which one is maximum and which one is minimum. So from this equation, what you are going to do, dear students, I'm just going to use a different color. If you solve this one, sorry, I made a small mistake here. It should be greater than equal to 0, not equal to 0. It should be just a minute. This should be greater than equal to 0. Now, if I look into it, so we'll get, three different ranges of values of y. The first case should be y belongs to the closed interval AB. If we get this thing, we'll see in another few minutes we will solve some problems together. If we get, after solving this quadratic inequation, if we get y belongs to the closed interval a comma b, what we can conclude? We can conclude that minimum value is a and maximum value is b. Correct? So from here what we can say is that y mean is equal to a and y max is equal to b. Now, if we get, after solving this, if we get something like this, that y belongs to minus infinite to a closed interval union closed interval b to infinite. What we are going to get, dear students, then? that y mean, this will imply y mean is equal to minus infinite, that is not defined, and if we get, and y max, what we'll get? Y max will be infinite, that is also not defined. So this we get. And the third case, what we can get, dear students, that it may possible that this for any value of x, the y we are getting is that y is actually minus infinite to plus infinite. Minus infinite, so let me write properly. Y belongs to minus infinite to plus infinite. This implies y mean, that is equal to minus infinite, which is not defined, and y max is equal to plus defined, that is also not defined. Dear students, is it clear that when you solve this quadratic inequation, as you see, this quadratic inequation, if we give this as 2, then these are the three possible cases may happen. First one is that y belongs to the closed interval a comma b. At that time, what we can conclude? Okay, minimum value of y is a and maximum value of y is b. That's what we wanted to find. And second case, what we can see is that if we see that y belongs to minus infinite to a union b to infinite, a and b are in closed interval, and obviously minus infinite and plus infinite should be open interval. So in that case, what we find, the minimum value is minus infinite and maximum value is plus infinite. In both the cases, it is not defined because you cannot reach infinite. And in the third case, what it can be, that y belongs to the open interval minus infinite to plus infinite. In this case, y mean that is equal to minus infinite, not defined, and y max that is also plus infinite, not defined. So with this principle, what we are going to do, dear students, we are going to solve some problem together. And here are the problems I'm going to discuss. But before that, what I want to do is that I want to show you the underlying theory. Whatever I just discussed, I'm just going to write down this thing so that you can follow it also later. I hope you are able to view it, dear students.
Yes, sir.
Okay, great. The first question, you can have a quick look into it, and after that, we will discuss the first question. And please open your notebook as well so that we will solve this problem together. The first question, dear students, is something like this. Question is that if x be a real, so that the expression x square plus 2x minus 11 by x minus 3 can take all values which do not lie in the interval 4 to 12, that is open interval 4 to 12. Okay, let us solve together and let's see that how we can conclude, how we can prove this thing. So dear students, first and foremost, what is the technique here? The technique here is that to solve this kind of problem, first you take y is equal to x square plus 2x minus 11 divided by x minus 3. I am doing it slowly considering all of you, but you can do fast. From here, what you need to do? From here, first you need to find a quadratic equation in x. If we find a quadratic equation in x, so how to find it out? So this implies x into y minus 3 into y, that is equal to x square plus 2x minus 11. This implies x square plus 2 minus y into x plus 2 minus y into x plus 3y minus 11 equal to 0. 3y minus 11 is equal to 0. Now from here, dear students, what we are going to get is that, okay, if you look into this particular quadratic equation in x, what we see? We see that the values of x and y are related by this equation, and for all values of y, or I can say for each and every value of y, what we get? X is a real number, which is the root of this quadratic equation 1. So now we see that the equation 1 is a quadratic equation in x and x is real. Definitely the discriminant must be greater than equal to 0, because for x being real. So what is the discriminant? B square, 2 minus y whole square, minus 4 into a into 3y minus 11 is equal to 0, since x is real. So now from here, what we get? From here we get a quadratic equation in y. I'm so sorry, quadratic equation in y. So I made a mistake. That should be greater than equal to 0. Correct, no, dear students? So it is 4 minus 4y plus y square minus 12y plus 44 is greater than equal to 0. So from here what we get, y square minus 16 into y plus 48 plus 48 is greater than equal to 0. Now we can do a splitting of the middle terms. If we split the middle terms, dear students, so what we get, y minus 4 into y minus 12 is greater than equal to 0. Now recall our the previous knowledge, x minus alpha into x minus beta greater than equal to 0. That means either x is greater than maximum of alpha and beta, or y is less than equal to minimum of alpha and beta. But in context to our inequality, what we just found, that is y minus 4 into y minus 12 greater than equal to 0. Here you can take alpha as 4 and beta as 12. So that means either y is less than equal to 4 or y is greater than equal to 12. So this implies either y is less than equal to 4, or it should not be and, or y should be greater than equal to 12. And that proves that y, that is this expression, the given expression, can take all values which do not lie in the open interval 4 to 12, because apart from 4 to 12 it can take every value. So this implies the given expression can take all values. Can take all values which do not lie in the open interval, which do not lie in the open interval. This open interval is very meaningful here, because the moment if you consider the value 4 and 12, then this is actually getting satisfied here. Correct? Or in other way, if I can represent this in the number line, how it looks like, dear students? So this goes to plus infinite, this goes to minus infinite, midpoint is 0. Then where is 4? 4 is here. So this we can assume as 4, and 12 is here. This you can assume as 12. So according to the inequality, whatever we found it out here, dear students, that either y less than equal to 4 or y greater than equal to 12, if we represent in the number line, so it should be something like this: either y less than equal to 4, less than equal to closed interval, so it is a filled up circle. You see, dear students, filled up circle, or y greater than 12. Here also filled up circle because 12 is included, closed interval. So these are the possible values of x it can take, which is you see in the green line. So that means what it cannot take? It cannot take the value of y, cannot be between 4 to 12, open interval. I hope it is clear, dear students.
Yes, sir.
Okay. Now the next question I'm going to give you, and let us all solve together. And here is the question. This is the second question, and I want you to solve it and do let me know. Please take some time and then solve it. So here the question is, so that by giving real values of x, the value of the expression is always real. And what is the expression? 4x squared plus 36x plus 9 divided by 12x squared plus 8x plus 1. Okay, I hope you already started working on it. So let me also start and you can let me know how we are proceeding. So as you know that first you need to assume y is equal to 4x squared plus 36x plus 9 divided by 12x squared plus 8x plus 1. And from here, dear students, what you need to find is that you need to find that, quadratic equation in x. So if you make a quadratic equation in x, so it should be something like this. 4 minus 12y into x squared plus 36 minus 8y into x plus 9 minus y is equal to 0. Now look into this quadratic equation. Now, in order that x may be real, it is necessary that, and also sufficient at the same time, that the discriminant of this quadratic equation 1, must be greater than equal to 0. So what is the discriminant? Discriminant is that 36 minus 8y, that is b square, minus 4 into a. What is a? 36, 4 into 4 minus 12y, 4 minus 12y into 9 minus y, that is, greater than equal to 0. Now, if we start solving it, dear students, that if we can simplify it, you can simplify and you will get something like this, that y square minus, I'm not performing all this intermediate simplification because that you can do, plus 72 is greater than equal to 0. Now, that is always true. How come you know? There are two ways you can prove it. This is always true. The first way of proving is that very, interesting information, whatever we learned in the last class, and which is available in the YouTube, you can look into it, is that we see this is an quadratic inequation in which the coefficient of y square 1 is greater than 0 and the value of that inequality also greater than equal to 0. That means the discriminant must be less than equal to 0. Let me see that whether the discriminant is less than equal to 0 or not. So what is the discriminant? It is 8 square minus 4 into 72. That is always less than 0. So that is by default true. That means it is true for any value of y. This is one thing. Another approach could be, dear students, is that which is a conventional approach. So from here, what we can get? From here we can make a complete square. So we can write y minus 4 whole square. Correct? Now, so then plus 56 greater than equal to 0. Correct? So this implies what? This is true for any value of y. This is true. This is true for any value of y. Correct or not? As it is true for any value of y, what we can say is that we can say that definitely that you know the value of this expression, that is 4x square plus 36 plus 9 divided by 12x square plus 8x plus 1 is true for any value of x. Correct? I hope you got my point. Clear or not clear? Now let us look into the next question, dear students. And the next question is something like this. It is in a little different way I am just framing this question. And the question is something like this. Find the range of the expression. Find the range of the expression tan square theta minus 2 tan theta minus 8 divided by tan square theta minus 4 tan theta minus 5 for all permissible values of theta. The moment the question is that find the range of the expression, that means you will find with an interval, right? The upper bound of the interval being the maximum value of that expression, and lower value of that interval is going to be the minimum value of that expression. Correct, no? So now let's find it out, how to do this thing. So if you look into this expression, dear students, that first and foremost, the relationship between that algebraic function and trigonometric function, that how we can make it is that first you assume tan theta is equal to x. So what is our initial expression? Initial expression is equal to y equal to tan square theta minus 2 tan theta minus 8 divided by tan square theta minus 4 tan theta minus 5. Now let tan theta equal to x. If we assume tan theta equal to x, this implies y is equal to x square minus 2x minus 8 divided by x square minus 4x minus 5. Now the same process means what, dear students? Let us express this equation, or we can say let us transform this equation to a quadratic equation in x. And if we do this thing, dear students, so you will get something like this. You can do quickly. Okay. So it will be something like this. Y minus 1 into x square plus 1 minus 2 into 1 minus 2y 2 into 1 minus 2y into x plus 8 is equal to 0. I'm sorry, plus 8 minus 5y should be plus 8 minus 5y is equal to 0. Now as x belongs to R, I'm just writing in a different form like the previous one, different way I am saying, but it actually saying the same thing. Means as you see, this equation 1 is a quadratic equation in x where x is real. That means as x belongs to R, definitely the discriminant, the way we define discriminant as d must be greater than or equal to 0. So what is the discriminant, dear students? So this implies 4 into 1 minus 2y whole square b square minus 4 into AC y minus 1 into 8 minus 5y for AC is greater than or equal to 0. Correct? So from here what we can say, dear students, this implies 4y square minus 4y minus 1, 4y square minus 4y plus 1, okay, minus 13y minus 8, 13y minus 8 minus 5y square is greater than or equal to 0. And if you simplify further, dear students, you will get something like this: 9y square minus 17y plus 9 is greater than or equal to 0. So now there are two ways you can do it. One is that completing the square, that you can do it. Also another thing is that the quickest method is that we see that if this is greater than or equal to 0, then what we can conclude? We can definitely conclude that is only possible to have a greater than or equal to 0. The coefficient of y square is what? Is 9. Coefficient of y square of 9, that is greater than 0. And the discriminant d is what? Here the discriminant is, suppose discriminant is equal to b square minus 4ac. That is equal to 289. I'm just writing in short. 289 minus 324. You don't need to find the value, but you understood that this is less than 0. So what we see is that, if you find this inequation is true, this implies what? The inequation the inequation 2 is true for all y. Okay. So this implies what? This implies the range of y is minus infinite to plus infinite open interval. So though the question is given in the form of a trigonometric one, but you see that how we convert it to a algebraic one by means of the substitution. And after that, there is no way the value of tan theta is coming into the picture. Correct?
Yes, sir.
Good. The next question, what I'm going to do, dear students, is something like this. And I appreciate that you also do along with me. A little different type of question, but concept remains the same. Here the question is that find the value of m for which the expression 2x square minus 5x plus 3 divided by 4x minus m can take all real values for x belongs to r minus m by 4. R minus m by 4 means x can take any real number except the value 1 m by 4. Okay. Now, how to solve this question? First procedure remains the same. That let us take y is equal to 2x square minus 5x plus 3 divided by 4x minus m. Same traditional process, that y is equal to 2x square minus 5x plus 3 divided by 4x minus m. And from here, all we can form is an quadratic equation in x. If you form a quadratic equation in x, it should be something like this: 2x square minus 4 into y plus 5 into x plus 3 plus my. This is equal to 0. Now, as x belongs to R, definitely the discriminant d should be greater than equal to 0. Now, what is the discriminant here, dear students? It is 4y plus 5 whole square. Actually, it is minus of 4y plus 5 whole square, but minus 1 whole square is plus 1. That's why I'm writing 4y plus 5 whole square minus 4 into 2 into 3 plus my. So that is 8 into 3 plus my. That is greater than equal to 0. So let me write properly that greater than equal to 0. Discriminant has to be greater than equal to 0. Now let us, simplify it. If we simplify it, you will get something like this: 16 into y square plus 40 minus 8m into y plus 1 is greater than equal to 0. A quadratic equation in y is non-negative for all values of y if the coefficient of y is positive and the discriminant is less than equal to 0. Remember, dear students, this is only possible. This is possible means 16 should be greater than 0 and the discriminant of that corresponding polynomial equation from the inequation, if you can tell that equation, that is equal to and 40 minus 8m, that is b square minus 4 into 16 into 1, that should be less than equal to 0. That is the underlying condition. So now 16 is greater than 0, so it is universal truth. So we only bother about 40 minus 8m whole square minus 64 is less than equal to 0. Now, what we can do is that we can take 4 common from that 40 minus 8m, so that becomes 16. So finally it will happen that 16 into, it is in fact we can do it little better way. we can write not 16 only, we can take 64 common. Yes, we can take 64 common. Then it is 5 minus m whole square minus 64 is less than equal to 0. This implies 5 minus m whole square minus 1 is less than equal to 0. So now let us simplify it. You can also do, in fact, you can do faster than me. I am doing slowly. Take care of all the students. 25. Okay. 5 minus. So you can write it here is that 25 minus 10 into m plus m square minus 1 is less than equal to 0. From here we get m square minus 10m plus 24 less than equal to 0. That is equal to m minus 4 into m minus 6 is less than equal to 0. So now what we can say is that from here m, so from here we get, if you recall dear students, that x minus alpha into x minus beta is less than equal to 0. That means x is in between the minimum of alpha and beta and maximum of alpha and beta. That means what we can say is that 4 less than equal to m less than equal to 6. Looks like that, okay, this is the answer, but no, there is a catch, small catch. If you put m equal to 4, okay, then what are we going to get? Because we have never used this condition. This condition what is given now, that we have never used. So we need to use this condition. Now in order to use this condition, what we need to think of is that first you put m equal to 4. Now if you put m equal to 4, dear students, so what we are going to get if we put m equal to 4? Then what is the value of y you are going to get? The value of y you are going to get is that 2x minus 3 into x minus 1 divided by 4 into x minus 1. So this implies what? This implies y is equal to 2x minus 3 by 4 subject to the condition that x is not equal to 1. Now this implies what? As x is not equal to 1, okay, then y cannot be equal to minus 1 by 4. Hence, y cannot take any real value for m equal to 4. So, m equal to 4 is not acceptable. I repeat, dear students, what we see from here, y cannot take all real values for m equal to 4 because there is a value now, 1 minus 1 by 4, okay, for which, we see, x is not equal to 1. Correct? So what we can see is that m equal to 4 is not acceptable. So from here what we can say is that, from here we can say is that y cannot take all real values y cannot take all real values for m equal to 4. Y cannot take all real values for m equal to 4. From here, what you can conclude? That m equal to 4 is not acceptable. This implies m equal to 4 is not acceptable. In the same manner, we can observe that for m equal to 6 also it is not acceptable. So for m equal to 6, what we are going to get? We are going to get y is equal to 2x minus 3 into x minus 1 by 4x minus 6. That means 2x minus 3, again we can take common now. So this implies y is equal to x minus 1 by 2. So that we can write is equal to what? 2x minus 3 into x minus 1 divided by x minus 1 divided by 2 into 2x minus 3. So we can write this is equal to x minus 1 by 2 if 2x minus 3 is not equal to 0. That means what? X is not equal to 3 by 2. If x is not equal to 3 by 2, okay, so y cannot be equal to 1 by 4. This implies equal to what? If x is not equal to 3 by 2, so that value of 3 by 2 you will put it here now. Y is equal to 3 by 2 minus 1. 3 by 2 minus 1 is actually 1 by 2. 1 by 2 by 2 is equal to 1 by 4. So what we see is that y cannot be equal to 1 by 4. So this implies y cannot take all real values for m equal to 6. So from here what you can say? M equal to 6 is not acceptable. So what we see, dear students, is that from whatever we got, that 4 less than equal to m less than equal to 6. So by means of this and this, what we can conclude, that 4 less than m less than 6. So that implies m belongs to open interval 4, 6. Correct, not your students?
Yes,
Good. Before we conclude our class, I just would like to give you one question that you can solve it, and do let me know. And the question is here. Find the ranges of the expression. And what is that expression? That you are going to get it now. Find the range of the expression cot square theta plus 5 into cot square theta plus 10 divided by cot square theta plus 1 for all permissible values of theta. Okay. So I suggest you to please solve it and to send me sometime today. And tomorrow we'll discuss a new topic. With this, I would like to conclude the class, dear students, here, unless you have any specific question. Okay.
No, sir.
All right. Thank you.